ฮัลโหลฮัลโหลฮัลโหลฮัลโหลครับผมก็วันนี้นะครับเป็นวันสอบปากเปล่าขั้นสุดท้ายนะครับของคุณปิยะโกษาวิทย์นะครับเป็น thesis ระดับปริญญาโทนะครับหัวข้อ The effects of composition and particle size of lighthouse ash นะครับ on the Portland cement based solidification นะครับเดี๋ยวเชิญคุณปิยะนะครับแนะนำตัวเองนิดนึง
ภาษาอังกฤษนะวันนี้ใช้อ่ะ
เหรอครับ
เอาใหม่ไม่หรือเอาได้เดี๋ยวเขาพูดภาษาอังกฤษเขาทีเขา
ทางนั้นเชิญเลยครับ
ดีนะจันทร์อยู่ให้กันคุณโตให้ใครให้พี่คุณด้วย
Good afternoon, Professor. My name is Piya Kosati. Today I will present a master thesis in the topic of the effect of particle size and content of lighthouse ash from textile wastewater treatment on the property of Portland cement-based solidification. The topic that I will talk today consists of introduction, literature review, experiment, results and discussion, and conclusion. First, introduction. The symbolic that I will talk in today shown in this slide. C stands for calcium, S stands for silicate, H stands for hydrate, OPC stands for ordinary Portland cement, CH stands for calcium hydroxide, RSA stands for lighthouse ash, URSA stands for useless lighthouse ash. Cement paste, same meaning as paste. Cement paste is a mixing between cement and water. And mortar is mixing between cement, sand, and water. And concrete is mixing between cement, sand, water, and stone. First, solidification. Solidification of cement-based process is one of the best treatment methods before disposal. Solidification designed to calculate physics characteristic of liquid or solid and decrease release of hazard to the environmental. In this research, I choose cementitious material basis because we can bought it easy. We can buy cement in everywhere. The reaction of cementitious material bases shown in this slide. First, added reaction. Calcium silicate hydrate has metric ion become metric calcium silicate hydrate. And the second reaction, substitution reaction. Calcium silicate hydrate plus a metric ion become metric calcium silicate hydrate and calcium ion. In the solidification process, these two reactions generate both. Next, pozzolanic materials. Pozzolan are silicate-based material that react with the calcium hydroxide from hydration reaction to generate from the cementitious material. Hydration reaction is the reaction between cement and water. When cement and water react, the product of this reaction is calcium silicate hydrate and calcium hydroxide. Calcium silicate hydrate is the main strength of concrete or cement. Next, pozzolanic reaction. Pozzolanic reaction is reaction between pozzolan, water, and calcium hydroxide. That is a byproduct in hydration reaction. The product of this reaction is calcium silicate hydrate. The ASTM standard specification for natural pozzolan, they give a specification shown in this table. Next, objective and scope of work. First, objective. First, to determine the optimum condition for RSA on the Portland cement-based solidification. Second, to determine the relationship of RSA composition and particle size on solidification property. Third, to suggest the utilization of RSA based on solidification properties. Scope of work. In this work, we molding the mortar. The condition in this experiment consists of two conditions. First, fixed water condition. Fixed water meaning to fix water to solid ratio equal to 0.75. And the second condition is fixed flow condition. Fixed flow condition means vary water to solid ratio that can make the flow ability equal to 110. The mortar size in this explained size is 125 cubic meters. Time formula RSA was at 15, 30, 60, 90 minutes and 24 hours. And curing time was at 7 and 28 days. Next is literature review. First, Busabong 2000. Busabong he bring RSA unmill and mill for 25 minutes and he substitution for 20 and 40%. He molding the mortar and he also fix the water to solid ratio at 4.4, 0.5 and 0.6. Curing time in this experiment was at 3, 7, 14 and 28 days. He also fixed solid to sand equal to 1 to 2.75. He reported that RSA unmilled in the size of 100 to 1000 micron and RSA mill size 1 to 100 microns. He also found that his NiHS contains silica oxide 78%, alumina oxide 0.3%, iron oxide 0.2% and sulfur oxide 0.09%. That is passing the standard specification for phosphonic materials. The parameter that he measured consists of first shrinkage, compressive strength, tensile strength and corrosive resistance. First shrinkage, he reported that RSA substitution made cement has lower shrinkage than control. This shrinkage can, if they have high shrinkage, this will cause the cement cracking. Compressive strength and tensile strength. He reported that compressive strength and tensile strength of RSA mill was larger than RSA unmill. And the compressive strength and tensile strength were decreasing with the percent of RSA substitute. Next is corrosive resistance. He found that corrosive resistance was a function of percentage of RSA substitution. And RSA mill 75 minutes has lower corrosive resistance than RSA unmill. Next, Chatbira and Mukhamdan 2001. He bring RSA to substitution for 20 and 40 weight percent and he choose the one of RSA mill at 75 minutes or RSA mill for 3 hours. He molding the concrete by varying the water to solid ratio at 0.5, 0.6 and 0.7. He fixed the solid to sand to gravel equal to 1 to 4. He reported that his RSA consists of silica oxide almost 97% and alumina oxide 1.6%, iron oxide 0.5% and sulfur trioxide 0.1%. That is passing the standard specification for national porcelain. He found that the RSA unmill has average particle size 539 micron. RSA unmill has average particle size 44 micron. RSA mill for 3 hours has average particle size 23 micron. And he chose the RSA mill for 3 hours to use in this experiment. The parameter that he measured, first, slump test. Slump is a told that how easy to cement or to concrete fall. Next is unit weight. Unit weight told that how concrete weight. Is it light or heavy? Compressive strength. Modulus of elasticity. Modulus of elasticity is the ability to tell that how resistant to deformation. And then temperature of hydration. He reported that slump of fine RSA concrete was lower than OPC concrete. And the unit weight of fine RSA concrete decreased with when RSA replacement were increased. The compressive strength after 28 days curing of fine RSA concrete 20% was higher than OPC at water to solid ratio equal to 0.5 and 0.6. The result of concrete mix 20% was have a higher compressive strength than OPC because the silica amount in RSA contains 20% react with calcium hydroxide completely. There is not silica remain or calcium hydroxide remain. Therefore, they can develop strength higher than OPC. He reported that the modulus of elasticity of fine RHA concrete was slightly lower than OPC concrete. And he also reported the temperature of hydration of fine RHA concrete was lower than the OPC concrete in every meter. Next, Piyapanuwat and Aswapisi 2009. He bring RHA and sludge to substitute cement. The percentage of RHA substitution was at 20 and 30 weight percent, and sludge at 30 and 50 weight percent. He molding the mortar. He varied the flowability equal to 110, and he fixed solid to sand equal to 1 to 2.75. He reported that his RHA consists of silica oxide 93%, and RHA that he used was passing milling process for 4 hours. And he reported that the particle size after milling was less than 45 micron. The parameter that he measured is compressive strength and leachability, and he also compared with the standard for landfill. He reported that there is no stain were observed during the first 7-day curing when mixed the OPC with slag by without the RHA. And at the highest percentage of both material, at 30 weight percent of RHA were used to substitute, and 50% weight of slag were used to substitution. They gave a compressive strength equal to 4.5 KSC at age of 3 days. That is enough for that is passing the standard for landfill that require only 2.5 KSC. And the leachability, he reported the leachability of zinc and chromium from the solidified waste was not exceed than the criteria for disposal. Next, Dabai 2009. He bring RHA to substitution the cement at 10, 20, 30, 40, and 50 weight percent. He molding the mortar at curing time 3, 7, 14, and 28 days. He fixed flowability at 110. He also fixed sand to solid ratio equal to 1 to 2.75. He reported that his RHA consists of silicon oxide 68%, alumina oxide 1%, iron oxide 0.78%, and sulfur dioxide 0.1%. If you plus these three composition, you will find that it is not equal to 70%. He reported that this is not a good for porcelain. The parameter that he found is compressive strength and setting time. Setting time is time to change from a fluid state to rigid state of cement. He reported that the base compressive strength we saw was of 10 with a percentage of replacement at 10%. And the trend of compressive strength were decreasing with the percentage of added. He also reported the initial and final setting time increase with increase in fly ash add content. That means the added of fly ash add will slow down the rate of reaction that makes cement has more initial and final setting time. Next, Chatwira 2012. Chatwira, he bring RHA mill for 4 hours to molding with Portland cement sulfur resistant type and limestone 2 size. First is limestone size less than 100 micron and limestone in the size length of 100 to 600 micron. He reported that RHA mill for 4 hours has size in the length of 0.1 to 100 micron. He reported that his RHA consists of silicon oxide 88%, and alumina oxide 0.8%, iron oxide 1%, and sulfur dioxide 0.02%. The parameter that he measured was consists of water requirement, compressive strength lost by sulfate, and shrinkage. He found that the RHA and limestone reduced the water requirement. He reported that the compressive strength of RHA and limestone substitution were lower than control or Portland cement sulfur resistant 100%. And he reported the higher percentage replacement of RHA mill and limestone in Portland cement type 5 will make the strength loss and shrinkage lower than the control. The shrinkage as also as the same result as compressive strength. And he also reported the optimum condition in this experiment were at cement 80%, RHA 10%, and limestone 10%. Next, Oblate 2014. He bring the RHA to substitution cement in concrete for 5, 10, 15, 20, and 25 weight%. He molding the concrete at curing time 7, 14, and 28 days. He also fixed the solid to sand to gravel at 1, 2, 2, 2, 4. He reported that RHA size was less than 600 microns. The parameter that he measured is compressive strength, bound density, and compacting factor. Compacting factor is a parameter that told how the cement packed into the form. He reported that the compressive strength of concrete reduced as the percentage added of RHA. The bound density of concrete reduced as the percentage of RHA replacement increased. The result of bound density were nearly as the unit weight as the previous study. The compacting factor value of the concrete reduced as the percentage of RHA increased. And he reported the optimum addition of RHA as partial replacement for cement is in the range of 0 to 20% weight. Next experiment. First, material and equipment. The material and equipment we have used in this slide. First, RHA. We can buy RHA at Talat Thai market. Next is fine sand. We also buy at the construction shop near Future Park Transit. And the cement that we use in experiment is ordinary Portland cement type 1 TBI lead. And the mill we use ball mill. And mixer, we use the mixer that following the ASTM standard for molding mortar. And here is a compressive strength tester at MTech. Mixing procedure. First, we mixing between RHA, sand, water, and cement following the ASTM standard. After finished mixing, we measure the flowability. After that, we molding them into the mold. The step two molding is fill it in the half of mold, and then we blow up the air by using the hammer. Then we fill it into the mold until it's fulfilled. After that, we let them hardening in this mold for 1 day. After that, we curing them into the water 28 days and measure the compressive strength. This is a conceptual framework. We separate the experiment into 2 parts. First part, the objective of first part is to compare the property of RHA and URHA in cement-based solidification and to find the leachability of URHA at optimum condition and to choose the optimum condition for using in the next step of experiments. The parameter that we measure consists of microstructure by phase composition by using X-ray diffraction and the chemical composition by using X-ray fluorescence. This is a mixing proportion in experiment part 1. Control stand for cement 100%. R10 stand for fly hash at 10%. R20 and R30 also. U10 stand for use fly hash at for 10%. U20 stand for use fly hash at 20%. And U30 stand for use fly hash at for 30%. The molding condition, we fix water to solid ratio equal to 0.75 and solid to sand equal to 1 to 2.75. This is the result of the experiment in part 1. Chemical composition of cement and URSA and RSA. We found that our RSA has silica, alumina and ferrous oxide more than its requirement of standard. Therefore, this is the good for solar. And sulfur dioxide also less than 4%. Next is phase composition of RSA and URSA. In the blue line is RSA and in the pink line is URSA. We found that the main phase of RSA is silica in the form of cristobalite, and we also found the quartz form in some peak of pattern. And we also found the amorphous form hump into the cristobalite form here and here. That is the form that good to react with cement. This is the result of compressive strength in p-test of part 1. First, control. The control has compressive strength about 200 KSC, and when we added the 10% of fly hash, the compressive strength dropped to 140 KSC. After we substitute 20%, the compressive strength dropped to 80 KSC, and when we substitute 50%, the compressive strength dropped to 60 T. And during the molding process, we also measure the flowability. The result of flowability shown in this table. We found that the result of flowability in some sample cannot be measured, such as R20 and R30. But however, during the mold fabrication, we found that the R20 can flow easier than R30. And after we measure the compressive strength, we also compare with the standard. First is a standard for landfill. We found that the compressive strength of our RHA cement solidification was passing the standard for landfill and passing the standard for loading concrete masonry also. But you will see the standard for loading concrete masonry at U30%. We found that it is nearly the standard. And during the mold fabrication, we found that there are some cracking shown in this picture here. There are some cracking during the mold fabrication of R30 and U30. Therefore, this is not a good signature for using U30 and R30 in the next step of experiment. After we molding R10, R20 and R30 in fixed water condition, we molding R10, 20 and 30 in fixed flow condition also. We found that the compressive strength in the fixed flow condition was increasing. The increasing of compressive strength because the water requirement of R10 at 0.75 is not enough to react the water with the cement. That's why the compressive strength was increased. And we also compare with the standard. We found that they are passing through the standard because the compressive strength is increased. After that, we bring USA consists of 20% weight to find the reachability of them. And we found that the reachability of U20 was less than the standard. Therefore, it is safe to the environmental. And in the next step of experiment, there is no significance of reachability that we can use RSA or URSA for the next step of experiment. So I choose RSA 20% substitution to use in the next experiment. Next, conceptual framework part 2. Part 2, we will study about the effect of RSA meal. We separate RSA into two groups. First is RSA unmeal, and the second group is RSA meal. RSA meal consists of meal for 15, 30, 60, 90 minutes and 1 day. After milling process, we also bring them to find the particle size distribution and microstructure by SEM also. After that, we molding the solidification of them in the two conditions, fixed water and fixed flowability. And the parameter that we measure is complicit strength test and microstructure of cement paste at 7-day age, and cost estimation and economic feasibility, and discuss the optimum condition. This is a mixing proportion in part 2. Signature. Control stand for cement 100%. R20 plus 0, meaning to LH as 20% and 0 μ. And R20 plus 15, meaning to LH as 20% and μ for 15 minutes. And the others also 20% and then μ. In this, the condition in this part consists of two conditions. First, fixed water to fixed water condition. We fix water to solid ratio equal to 0.75. And for fixed flow, we vary them until the flowability equal to 100%. And we fix the solid to sand equal to 1 to 2.75. First, the result of particle size distribution of RSA. The average particle size of RSA shown in this table, and the specific surface area bed shown here. The technique that we use to find the average particle size, we use the laser particle size analyzer, master sizer. The result found that first, at the cumulative curve of RSA unmeal and meal, if we zoom into the range, the short range, RSA in the range of less than 140 micron, we found that RSA 1 day has a fineness, has the most fineness in this group. And then RSA meal for 60 minutes, and then meal for 90 minutes, and meal for 15 and 30 minutes is also nearly the same. And the last net, the most graph in this group is RSA unmeal. And the graph of the particle size distribution also show in the bottom graph. The trend is also the same. The RSA meal for 1 day is the smallest in this group. And then RSA meal for 60 minutes, 90 minutes, 50 minutes, 30 minutes, and unmeal. Next is microstructure of RSA. In the left hand is the microstructure of RSA unmeal. You will see it is a bar shape, very long, not rough. And after we mill it, it's hacking into many shapes. It is many heterogeneous, high heterogeneous of RSA meal. And meal 30 minutes is also the result nearly the same. And RSA meal for 60 minutes and 90 minutes show in this slide. In the left hand side you see there are many shapes and many signs of RSA meal in both RSA meal for 60 and 90 minutes. They are also heterogeneous. And this is ISA mu for 1 day. This is the special one because the all particle of RSA mu for 1 day become a dust like. The particle size very small and is affect to the microstructure. One that affect to the microstructure in this group. Next is relationship between average particle size and water requirement. The green line shows the water requirement in fixed water condition. And here when the meal time increase, the water requirement was reduced. But there is some special in the ISA meal for 15 to 90 minutes. The average size were increased might be due to the heterogeneous of RSA. Next, compressive strength. The compressive strength of fixed water condition shown in the blue graph, and the compressive strength of the fixed flow condition shown in the orange graph. First is control. Control has a compressive strength about 200 to 220. At ISA and mu, the compressive strength dropped to 80. After mu for 50 minutes, the compressive strength increasing a bit in both fixed flow and fixed condition. And for ISA mu for 60 minutes, the compressive strength were nearly the same. And for ISA mu for 90 minutes, the compressive strength is just increasing a bit. And the special one is ISA mu for 1 day. We found that the compressive strength of ISA mu for 1 day more than the control. This is seen to be we can use it instead of cement in the future. And the trend of compressive strength were increasing when meal time was increased in both fixed water and fixed flow condition. Next, relationship between water requirement, compressive strength, and meal time. In the orange line is the compressive strength in fixed flow ability condition, and the blue line is the compressive strength of fixed water condition. The green line is the water requirement. We found that when the meal time increased, the compressive strength in both conditions were increased, and the water requirement was reducing. Next is microstructure of SEM test. In the top left is the control. We found that there are some rod shape, needle shape. Here you will see the picture. This is called ethylene phase that caused by alumina. This phase can develop themselves quickly and show in the early day. And you will see there are some plane here. Here it is a calcium silicate hydrate that develop themselves slowly. That this is makes cement strong. And you will see the RSA and meal or meal 50 minutes, 30 minutes has nearly the same of microstructure. And RSA meal for 60 minutes and 90 minutes also, we also found the ethylene and some calcium silicate hydrate. And the special one is RSA meal for 1 day. We could not find the ethylene phase because the RSA will be insert themselves into the core between the ethylene that makes cement stronger, compact, more compaction. So we can conclude that RSA will fall in the short period. They did not affect to the microstructure, and in the bottom line here is the SEM pace of control at 28 day. The phase development we cannot found in active guide, but we also found in calcium silicate hydrate phase at the all plane of SEM. Next, power consumption and electric cost. At the top is the fixed water condition, and at the bottom is the fixed flow condition. We found that the compressive strength increased, but the electric cost or power consumption were increased also. And at the 1 day meal, the compressive strength is just increased double time from ISA meal for 90 minutes. This is seen not good for economy because double compressive strength, but the power consumption or electric cost just 15 times of ISA meal for 90 minutes. And the result of fixed water and fixed flow is also the same. However, we cannot estimate how it is good for profit or good of economy. We have to use the profit index to evaluate it. The profit index equal to compressive strength index divided by cost index. The compressive strength index equal to compressive strength divided by compressive strength of RHA annual, and cost index equal to cost estimate divided by cost estimate of RHA annual. I in this here stand for R20 plus 0 or R20 plus 15 or R20 plus 1 day. The profit index, if profit index more than 1, that means we can get the profit, or equal to 1, that means no profit, no loss, and less than 1, that means